Okay. So I'm recording now, I believe. Let's make sure. Yep, it's recording now. Okay, so I hear some shuffling, which I don't think it's me. If you're coming into the room just now, will you please mute your microphone? Um, that's not to say I want it to be on mute the whole time. If you have questions, probably the easiest way is to just unmute yourself and then say something. So note, I'm not going to hear you unless you unmute yourself. And usually I want you muted, but if you want to ask a question, it's going to be hard to raise your hand because I can't see all of you simultaneously. So I can hear you all though. So just unmute yourself and try and interrupt at a strategic place to ask your question, or especially if I give opportunity to ask questions, which I will do. Let's see, I'm trying to think if there's so today we are going to have an in-class quiz to review some of the stuff from last time and some of the stuff that we're going to talk about today. So the in-class quiz will cover some stuff from chapter 2 and 3, and then we're also going to have the quiz, which was planned regarding origin of consciousness, the readings on book 2, chapter 5 and 6, which we're due today. I guess before we get started though, I'm going to do some lecturing on chapter 3 before we get into those quizzes. I just want to give you guys the opportunity, if you have questions in general about things that are going on in the course right now, or my expectations regarding the course going forward. Anyone have any questions? If so, just kind of speak out.
I just wanted to make sure that the quizzes that we are doing today, they're due tomorrow at midnight. I think that's what the email said.
Yes, that is my intention. I believe. I guess I have not put up the turn-ins on Blackboard yet. I'll do that once I assign them today. But yes, I'm going to give you more time than I usually would, because some people are not even going to be able to watch classes live. They'll have to do it on YouTube. Which reminds me, I'm recording this, so everything that we're doing here today is going to be recorded, and you'll be able to watch it on YouTube later. And because this is a long class meeting, we're not going to go the full 3 hours, that's for sure, but I'm going to probably break the videos up into part 1 and part 2. So I plan to give you a break for part 1 and part 2 of this class. And then, like part 3 of the class today will be when you guys are doing your quizzes. For that, I'm going to expect you guys to use Zoom by yourselves. And then if you have questions, I'll be by my computer for the remainder of class. If you have questions, then we can resume with me. So you'll Zoom with yourselves during the quizzes if you want to work with each other. And then if you have questions for me, which I know a lot of times you guys do, I'll be sitting here and you can log back into this meeting room right here and I'll answer your questions. Are there any other questions or comments people have regarding things going forward? Okay. If there are no more questions, then I'll get started talking about chapter 3. And I want to review a few things from chapter 3 first. Because this whole chapter is about attention, and it's been a long time since let me move this down a little bit. It's been a long time since, it's not going to let me. No, it's not. It's been a long time since we have, okay, that'll work. It's been a long time since we've talked about anything, so it might be helpful to just kind of review some of the things that we talked about last time. So we talked about this idea of selective attention versus divided attention, which are these two terms which are shown here. And I'll probably have a question on tests for you guys. It'll be test number 2, which just a definitional type of question, which requires you to understand how selective attention and divided attention differ. But we've talked a lot, so you can see their definitions there, but we've talked a lot about a type of selective attention, this shadowing task. The shadowing task is a type of selective attention, because usually in the shadowing task, you're told to pay attention to one thing while ignoring the other. Do you guys remember what is the thing? Someone speak up. What is the thing that you're told to pay attention to in the shadowing task, and what is the thing that you are ignoring? Anyone remember this? I'm thinking, what are the things that you pay attention to, and what is the thing that you are ignoring in this shadowing task?
I think in the example from class last week, or not last week, I guess it was like 3 weeks ago, but I think it was listening to someone speak on one headphone from one ear and trying to ignore the voice in the other headphone or the other ear?
Exactly. Fix my screen, by the way. My head's getting cut off. Okay, yes, you're exactly right. In the shadowing task, you're paying attention to one ear and you are ignoring what's in the other ear. So that's an example of selective attention, because if you look here, you're processing one stimulus, an ear, the message in one of your ears, while ignoring another message, which is the message in your other ear. So that's an example of selective attention. And the reason the shadowing task has been helpful for research on attention is because it's been relevant to this debate. Let's see here. There we go. On early selection versus late selection theories. And these are theories which basically are asking questions about when we're paying attention to something, what is the information that we're allowing to reach consciousness? And what is the type of information that we're inhibiting that it's not reaching our consciousness? When does this inhibiting occur? What information is being stopped? And we're allowing the other information to pass through, but some of the information is being stopped. That's in theory what attention is doing. Where is this occurring? Is it occurring in early processing or is it occurring in late processing? And we talked about some evidence for early processing, that when you're paying attention to something, what you're doing is you are deploying it early, and the evidence comes from this research right here. When you're doing the shadowing task, well, you guys tell me, when you're doing the shadowing task, if you're trying to pay attention, if you're paying attention to one thing, the message in one ear, and then in the other ear, you're trying to ignore this message, and in the other ear, it starts in English, but about halfway through, the message changes to this person in the ignored ear speaking Russian. Would that be something which would be hard for you to notice or easy for you to notice when the language is changing in your ignored ear, based on the findings that we talked about last time? Does this sound familiar at all?
I think the language change would be hard to notice, but I think you'd said that like a gender change or a pitch change would be easier to notice.
Yes. And so what that suggests is that this is evidence which is a support of this early selection, which I didn't mean to actually switch here, but this diagram is good. This is a early selection, evidence in support of early selection. The idea that the attention works before what is known as the perceptual channel. And the perceptual channel, in theory, is the part of your mind which allows you to understand the meaning of words. And so when you're paying attention to something, information about the meaning of words in your ignored ear is not getting to this perceptual channel. The meaning of the information, that is the language that a person is speaking, whether it's English or French, you're not processing the meaning of the words. And so none of that information is reaching your perceptual channel. However, the sensory memory or the sensory channel, that occurs before attention. So this is the reason why you're able to process a person's change in whether they're a man, like it might be a man who starts speaking and it changes to a woman. Someone tell me, what is the primary difference in the voice of a man speaking compared to a woman? Anyone remember this? What is the primary difference between a man speaking and a woman and their tone of voice?
Pitch.
It is pitch, and women would have a higher pitched voice. This would be considered a sensory feature. When a change in pitch, that is the change in a person's voice, occurs in your ignored ear, people are quite good at hearing it. Even if you're trying to ignore it, it's very salient. It's obvious to you. You notice it even when you're not paying attention, because this information is still reaching your consciousness, the information about the pitch. But when in the ignored ear, the information which is changing has to do with the meaning of the words. You don't notice that because the meaning of the words does not get to your consciousness. So this is evidence in support of early selection. And I encourage you, by the way, to read up a little bit about early selection in your textbook, because a lot of these findings are described in a little bit more detail in the textbook. And so it might be helpful to read about them there as well. Okay, so that's evidence in support of early selection. And now we'll talk about late selection. We talked about all this stuff last time, but we'll talk about it again. Evidence in support of late selection is that in your ignored ear, if you're paying attention to this ear, but then in this ear over here, you're trying to ignore what's in this ear over here. Studies indicate that when in this ear, if someone says your name over here, well, you tell me, are you good at hearing your name or are you bad at hearing your name in the ignored ear? Anyone know the answer to this?
Good.
Yeah, you tend to be good at hearing your name over here, which is evidence for late selection because your name is a word which has special meaning to you. And so this suggests, even though you're ignoring this, what this suggests is that some information about meaning is getting to your mind, is getting to your consciousness, even when you're not actually paying attention to it. This particular case is whether the word is your name or not, because your name has a special meaning. And even when you're not paying attention to stuff over here, information about your name is very salient or very important to you. And so it kind of pops out. It becomes very noticeable. So that's evidence in support of late selection. It suggests that even when you're not paying attention to something, that some types of meaning are reaching your mind. That specific type of meaning is whether it's your name or not. Another good example was, well, you guys remind me, there's this sentence here, they were standing near the bank. The word bank is ambiguous. What are the two different meanings of the word bank here? What are the potential two meanings of the word bank in this sentence? Anyone know?
Would be a place that you go to like put your money, or it could be the bank of a river.
Yes, that is right. Those are the two different interpretations, a place where you can put your money or next to a river. And what they found in this research is that you hear in your attended ear, the ear that you're paying attention to, you hear the sentence, they were standing near the bank. And then in your unattended ear, they'll either say something about a river or they'll say something about money. And then they'll ask you a question about what was going on in your attended ear. What kind of a bank was it that you were hearing about in the story in the ear you were paying attention to? And what they find is that the meaning information, that is, whether you're talking about money or whether you're talking about a river, in the ear that you're not paying attention to, it influences your interpretation of the words that you're hearing in your attended ear. So this is another evidence in support of late selection. Even when you are ignoring something, some of the information about meaning is reaching your mind. It is reaching your consciousness. So one of the things that I want to point out is these early and late selection theories or ideas about attention are kind of in competition with each other. And there's actually evidence that supports both of them. And so that's just something to pay attention to. I want you to pay special attention to the evidence in support of early selection theories that we talked about just a second ago, and the evidence in support of late selection theories. I don't want to talk more about semantic priming, simply because I know for a fact I'm not going to test you about it on test number 2. So here's the in-class quiz, and it is posted on Blackboard. I'm going to leave it here, but I don't want you guys to start working on it quite yet. Okay, so I think we talked about capacity theories a little bit last time. So the capacity theory of attention is, this diagram is quite helpful for understanding the capacity theory. This idea that we have a certain amount, a finite set of cognitive resources or of available cognitive capacity or just capacity, and that our attention is based, how well we are at attending to things in the world is based on how big our capacity is. And this diagram is helpful because it shows two different tasks, a primary task and a secondary task. And it shows how we can kind of simultaneously attend to two different things at the same time. Obviously, most of our attention will be devoted to a primary task, while relatively less of our attention would be devoted to a secondary task. But we're kind of doing two things. We're simultaneously paying attention to one thing with most of our attention, and a small percentage of our attention is simultaneously processing something else. This is the idea of attentional capacity, or just capacity. And so a related term is this term mental effort, which basically is the proportion of attentional capacity that you give any given task. So performing 2 tasks at once. Mental effort is basically the amount of attention you are giving each of those tasks. And so the book talks about, your textbook talks about several different ways of measuring attentional effort. One is verbal self-reports, which are probably the least interesting for a cognitive psychology class. Basically, you have a person performing a task and you just ask them, how much effort did that require? How difficult was that task that you were just performing? That's a measure of mental effort, how much effort it took a person to pay attention to something in a given task. Some more interesting for us ways of measuring mental effort are pupillometry and dual tasks, and we're going to talk about these in more detail in the subsequent slides. The finding that we're going to talk about regarding pupillometry, well, pupillometry, does anyone know what pupillometry is by any chance? Or anyone want to take a guess what pupillometry is?
Would it be the study of one that is your pupil? Like a student?
Good guess, but no, that is a good guess. It is the study of something, but it is not pupil as in a person who is your student. It is a different meaning of the word pupil. Anyone want to take a guess? And it's a physiological measure. That's another clue. Physiological meaning pertaining to the body.
Would it
To your
be
eyes.
Yes, that is it. It is the other meaning of the word pupil, which has to do with eyes, the size of your eye, particularly the size of your pupil. And one of the ideas here is that when you're paying attention to something, your pupil size, and the pupil, by the way, is the black part in your eye. When you're paying attention to something, it makes sense. Your pupil tends to increase. And when you're not paying a lot of attention to something, your pupil size tends to decrease. And so mental effort is basically measured by pupil size. The bigger your pupil size, in theory, the more mental effort you are using, the more difficult or the more cognitive resources it is requiring you to pay attention to something. So that's pupillometry. There's also some studies with infants that I'm not going to talk about too much. When infants are paying attention to something, like for instance, if you give them a toy and they're examining the toy, their physiological response as far as their heartbeat, usually their heart rate will tend to get slower. So when like for pupillometry in adults, when you're paying attention to something, your eye gets bigger. For infants, when they're paying attention to something, a physiological measure is their heart, and their heart rate tends to get slower. So there's all these physiological changes which are occurring when you're paying attention to something. The one we'll talk about most is pupillometry, the size of your pupil. We'll also talk about dual task. We've already been talking about dual task. The shadowing task is, in a sense, a type of dual task. You're paying attention to one thing, but you're trying to ignore something else. And specifically, the book talks about, this is a great example of a dual task. So the book talks about, it's a kind of a variation on the shadowing task that we talked about earlier. It's slightly different. And so in the shadowing task, which is described in the book, which I've paraphrased here, a participant is told to pay attention to one of 2 different types of things. They're paying attention to early information. So they would be given instructions like, pay attention to the speaker's voice in your ear. Or they'd be told to pay attention to late information, which would be like, pay attention to the meaning of the words that are being spoken. So early information is the pitch of the speaker's voice. Late information is the meaning of the words that the speaker is saying. And you as the participant are told to pay attention to one of those 2 things. However, there's a dual task. There's another thing that you're told to do simultaneously. And the thing that you're told to do simultaneously is, on a computer screen, you'll see a little flash of light that appears randomly. And while you're performing this task of listening with your ears, you also simultaneously have to be looking at your computer screen. And when there's a light that appears in your computer screen, you want to touch a button on the keyboard as quick as possible. So the 2 things you're doing here, the dual task, is you're listening to something in your ears, but you're simultaneously waiting for that light to appear on your computer screen. So that's the dual task. And the findings, I believe I described in the notes portion of the slides. And by the way, I strongly suggest you open the slides. I don't know if you can open them while I'm talking, but I have updated the slides. And so do make sure you take a look at the updated slides on Blackboard. In the notes portion of the slides, it does mention the findings from this study, that when people are told to pay attention to the meaning of the information in their ears, it makes it so that they are slower to respond to the light that appears on the screen. compared to the condition in which they're paying attention to the pitch of something in their ears, in which case they're relatively a little bit faster to respond to the visual light on the screen. So you tell me, does that indicate that which type of information requires more mental effort to pay attention to? Late information about meaning or the early information about pitch? If you're slower at responding to the flash of light on the screen when you're paying attention to meaning compared to when you're paying attention to pitch, that indicates that which of these two types of information requires more mental effort? You want to have an idea here?
That would mean,
Visual.
oops, sorry.
Yeah, one of you go ahead. I don't know how to choose you.
That would mean that the late selection information takes more mental effort to process.
Yes, exactly. You're paying more attention to the meaning of the information, which means you have leftover mental resources available. You have reduced capacity to pay attention to what's occurring on the computer screen. When you're really paying attention to the meaning of something, that means there's less attention or less capacity that allows you to pay attention to what's going on the computer screen, which results once again in you being slower to respond to a visual thing on your computer screen when you're paying attention to meaning compared to when you're paying attention to the pitch of something, in which case you're relatively faster at responding to the appearance of a light on the screen. Okay, so more on mental effort, but here's a variation on mental effort. This is the Stroop task. And in the Stroop task, you're using mental effort. You're using your attentional capacity to inhibit something. And the thing that you are, well, so let's talk about the thing that you're inhibiting in the Stroop task is known as an automatic response. And that is something that I want you to know what the automatic response in the Stroop task is for test number 2. And so let's talk a little bit about what a participant does in the Stroop task. In the Stroop task, your job as the participant is to tell the researcher the color of the letters that compose each word. And you guys, can you see the 3 different conditions here? Why don't you try and do that to yourselves for 10 or 15 seconds or so? Go through each of these words. And once again, what I want you to do is to tell me the color of the letters that compose each word. Maybe you could even say it out loud to yourself. Go ahead and take 10 or 15 seconds. Go ahead and do that, and then we'll talk about it here in a second. Take 10 or 15 seconds, the color of each letter that composes the words. Okay, so hopefully you guys have had a chance to do that. I'll go ahead and try some myself. Red, green, red, blue, blue, green, blue, red. Green, blue, red, green, green, blue, red, blue. That one was a little tougher for some reason. And then I'll try this one. Red, green, blue, green, red, blue, red, green. So I was just doing it. I'm curious to know your guys' opinions. In which of these 3 columns did you find the task to be the most difficult?
When the color doesn't match the word.
Yeah, this one right here is generally, actually the evidence is really strong, and I've replicated this in my own laboratory. It's a very strong effect. Reaction times to get the answer correct here are considerably slower. If you measure the amount of time it takes people to get to say each of these correctly, people are way slower for this, which is often known as the incongruent condition. Can you guys tell me what is the thing which is incongruent in the incongruent condition? In other words, what are the things that do not match with each other?
The color and the word.
Yeah, the color of the letters and what the word says. I would try and use language precisely here because I need to know which color you're talking about. I need to know if you're talking about the color of the letters or the color that the word spells out. And so try and be precise with your language on like tests and stuff, for instance. But yes, that is the correct answer, basically. The color of the letters, for instance, right here is red, but what the word spells out is green. And so those two things are in conflict. They are incongruent with each other. And so reaction times tend to be slowest there. And so what is the thing that you're in a Stroop task? What is the impulse? What is the response that you are having to ignore, that you are having to use mental resource to try not to do? What is the thing which is difficult to not do in the incongruent condition of the Stroop task?
You're trying
Say,
to read the word, the color word that it is spelling.
Yes, good. It was helpful that you said spelling. The thing that you're having to use mental effort to inhibit doing is reading the word. That is what you're trying not to do. You're trying to not read the word. You're trying to focus only on the color of the letters, but it's difficult. That's why reaction times are slower in the incongruent condition, because you're having to use mental effort to inhibit the automatic response. The automatic response in the Stroop task is reading what the word says. You're having to use your attentional abilities, your mental effort, your attentional capacity to inhibit that automatic response. And so you might have heard this term before, executive function. This is generally the term which is used to describe the mechanisms of the mind that support self-control. So you're using self-control here. You're using your attentional ability to not say the thing that your mind your mind says, read the word, and you're having to use self-control to not read the word. Executive function is the aspect of your mind which allows you to deploy self-control for tasks like this. So the Stroop task is a common measure of executive function because, once again, it requires you to inhibit a automatic response. And it's been helpful because you could study like clinical populations, that is people that have mental impairments. Particularly, you can study people that have impairments in executive function. And it's helpful to hypothesize, how would people that have an impairment in executive function, how should they respond in the Stroop task? And a common incorrect answer is people will just say, people with executive function impairments are just slowest for all of the different conditions of the Stroop task. But that's not entirely true. People with executive function impairments are really, really slow in the incongruent condition. So I'll say that again. Everyone is slow in the incongruent condition. But people that have attention problems, people that have executive function impairment, are particularly slow on the incongruent condition. Everyone's slow in the incongruent condition, but people with executive function impairments are particularly slow in the incongruent condition. And that's always relative to a control condition. So this right here, this is the congruent condition because the letters are red and they spell the word red. This could also be considered a control condition. And this could also be considered a control condition. And it says it right here. I was about to ask, but it says it right here. For all of these control conditions, you do not need to use mental effort to inhibit any type of automatic response. For the experimental condition, that is the incongruent task like this, you have to use mental effort to inhibit an automatic response. But for none of these trials over here, none of these conditions do you have to use mental effort to inhibit a response. So here's where we talk about pupillometry with relation to the Stroop task. Look at this graph. You guys can presumably see the slides on the graph. You guys can see the graph, correct?
Correct.
Okay, good. And if you could read it, I did maybe some practice reading it. Can you guys tell me that the y-axis is the size of your pupil? I guess it would be diameter of your pupil. And then each of the different color lines represents the different conditions. Two of them are control conditions, and one of them is the incongruent, that is the experimental condition. Can you guys tell me by looking at this graph, in which of the three conditions is the pupil size the biggest?
The incongruent.
It is the incongruent condition. And so what does this, well, I guess this is connecting to an idea that we were talking about earlier, that is pupil size is a measure of how much attention you are deploying, how much mental effort you are using. And in the incongruent task, you're having to use a lot of mental effort to inhibit the automatic response, the thing that you're trying to not do. That is taxing mentally. And so one of the physiological correlates of that is your pupil actually increases its size, at least according to this graph, according to the study, which is presented in the book. When you're using more attention, when you're using more mental effort, it tends to cause your pupil size to increase, at least in a subset of studies, including this one right here. Okay, so now I'm going to talk about another study. This is one that's not presented in the textbook, but it kind of goes along with this idea that when you have poor self-control, or when you have poor executive function abilities, when you have poor attentional abilities, this is going to cause you to have particularly slow responses in the incongruent condition of the Stroop task. And so here's a study, and here's the punchline, basically. Listening to dissonant music in the study I'm about to talk about causes a disruption in executive function. So if you have a disruption in your executive function, that should make it where you're slower, particularly slow to respond in the incongruent condition. So here are the data from this study. Let me see here. Yeah, allow you to see it. Over here is the incongruent condition. And we have these 3 different bars, and over here is the neutral condition. So this would be like different color letters, but all of the letters are X's. So this is the control condition of the study, and this is the experimental or the incongruent condition. But we also have these 3 different bars, and these 3 different bars are important in this study. And the legend is right here, explaining what these 3 different bars means. In the study, people were listening to different types of music while they were performing the Stroop task. The music was either consonant music or dissonant music or control. And in the control condition, they were listening to no music at all. And in case you're curious, the music they were actually listening to was a minuet by Mozart. And the consonant condition was just the minuet in its true form. In the dissonant condition, they were listening to the Mozart song, but they replaced some of many of the notes to make it sound like crappy music, like bad music, dissonant music, to be more scientific, I suppose. So those are the 2 conditions: listening to consonant music by Mozart, or listening to an altered dissonant version of Mozart, which sounds basically bad. People were listening to those different types of music, and while they were performing the Stroop task, and the researchers were interested, would performance in the Stroop task differ depending on the type of music that people were listening to? So first off, let me minimize this again. First off, someone tell me, in which of the 2 conditions, incongruent or neutral, were people's reaction times the slowest? Looking at this graph, in which of the 2 conditions, incongruent or neutral, were people's reaction times the slowest?
Incongruent.
It is the incongruent condition. And in the incongruent condition, can you remind me, what's going on in the incongruent condition? What is this? Anyone tell me what are the stimuli? What is going on in the incongruent condition in the Stroop task? In other words, how is the incongruent condition different than the neutral condition?
The color doesn't match the word that's spelled out.
Bingo. In the incongruent condition, the color of the letters is different than what the word says. In the incongruent condition, the word might say blue, but the letters which compose that word might be red. And so those are the things which are incongruent in the incongruent condition. And you can see that because these 3 bars, I'll minimize this again. You can see right here that these 3 bars are all taller than these bars over here. These are the incongruent condition, and these are the neutral condition. These bars are taller than this one, which is consistent with what we said. Reaction time is slower for the incongruent condition. That's what most of us experienced when we did the Stroop task ourselves just a second ago. It's harder in the incongruent condition. But looking at this, you can see that in one of these 3 conditions, one of the different colors, so we have red, blue, and white. In one of these 3 conditions, people's executive function seemed to be disrupted a lot, or more than the other conditions. In which of, so there's 6 bars here, in which of the 6 bars do we see evidence that people's executive function is disrupted? In other words, in which of these 6 conditions is people's performance in the incongruent condition, in the incongruent task, the incongruent condition, in which are people slowest to perform in the incongruent condition?
The ones who are exposed to
Say that again.
the ones who are exposed to the dissonant music.
Yep, the people in the, so we're looking at the incongruent condition right here, and we see the blue bar right here. These were the people who were listening to the dissonant Mozart music, and you can see that their reaction times were significantly slower. They had longer reaction times compared to the people that were in the incongruent condition but listening to the consonant Mozart, or the people that were in the incongruent condition that were just listening to no music at all. The people were particularly slow if they were listening to the dissonant music. So tell me again, out of these 3 different conditions right here, exposure to consonance, exposure to dissonance, and control, which one seemed to disrupt or impair people's executive function the most?
The exposure to dissonant music.
Yes, that is correct. Exposure to dissonant music. And we know that because this bar is higher than all the others. Exposure to dissonance seems to impair people's executive function. Moving on here. So the book does this is some interesting stuff actually that the book was talking about regarding the brain mechanisms that support attention. Particular, they talk about the brain mechanisms which are involved in inhibiting, and you can see it here, inhibiting an automatic response in some type of a task. In the brain, so it talks about these 3. It talks about mainly this cingulate gyrus, which the cingulate gyrus in this picture is basically a very large swath of the brain that includes many different regions, starting up over here. And by the way, you guys know what lobe is this right here that I'm circling? Can you tell?
Frontal.
That is the frontal lobe right there. So this includes the frontal lobe, the parietal lobe, maybe getting over here to the temporal and occipital lobe. So it basically covers all 4 of the lobes. So starting in the front and the back. But one thing, so it covers a lot of the brain. Another thing which is kind of difficult about the cingulate gyrus is it's actually located inside the cortex. So it's kind of hard to draw it on a brain because it's not on the outside of the brain. It's actually towards the inside of the brain. The cingulate gyrus, this big swath of brain that includes all the different lobes, basically, it's broken down in the book into these 3 different parts. The limbic region. So these are involved in inner parts of the cortex, and the typical, if you take my cognitive neuroscience class, we talk about it a lot more, but the limbic regions of the brain, which include things like the amygdala and the hippocampus, are thought to be involved with emotion and memory. And so that's part of this region which is important for attention. Another region is the basal ganglia, which is another inner part of the cortex towards the bottom parts of the cortex, which is important for bodily feelings and how they can lead to driving repetitive behaviors. For instance, the basal ganglia are important for, it's important for instance, how euphoric effects of drugs can be reinforcing to taking those drugs in the future, because there's a bodily euphoria with drugs, which increases the likelihood because of addiction that you'll reuse those drugs later on in the future. And so it's like euphoric feelings or bodily feelings and how those can influence different types of behaviors. And then the anterior cingulate is the 3rd region right here. This is the one which is probably most relevant to us talking about attention in this class. This is part of the frontal lobe. Here's the executive, this is the anterior cingulate. They don't actually have it labeled here, but this little blotch right here is the anterior cingulate, which is part of the frontal lobe. By the way, do you guys remember what anterior means? Have we talked about what anterior means? Anyone remember what anterior means, or anyone want to take a guess what anterior means?
Anterior means in the front.
Yes, that is right. Thank you. Anterior, I was about to say it because it was taking a while, but yes, anterior does mean towards the front of the brain in this case. And so the anterior cingulate is a frontal lobe structure. It's part of the cingulate gyrus, which is this large structure. The anterior cingulate is the frontal part of this. It's in the frontal lobe, and it's thought to play a particularly important role in inhibiting not doing certain types of automatic behaviors. Yeah, and the book talks about the anterior cingulate. They did, I think the book said it was an fMRI study. They did an fMRI study, and they showed that when people were doing the incongruent condition of the Stroop task, there was a lot of activity in the anterior cingulate, this region of the frontal lobe, which the researchers interpreted as saying this is a region of the brain which is important for inhibiting responses, because the evidence comes from the fact in the incongruent condition, the response in this brain region is the highest. So here's an example that I liked from the textbook. It's another example of inhibiting an automatic response. And so I guess I thought this was funny because I've dealt with this with my wife plenty of times. So usually when you're going home from work, you turn right to go home. But your spouse, I guess your husband or wife or whoever, significant other, asks you to pick up groceries after work. In the grocery store, instead of turning right when you leave work to go to the grocery store, you would have to turn left. And so, well, first off, what is the automatic behavior? We have these two things here, either going to the grocery store or going home. Which of these is assumed to be the automatic behavior that you have to inhibit?
Turning right.
Yes, turning right, going home. That's the thing that you do every day after work. You take the same route, you turn right when you leave work, and after a while, it becomes automatic. It becomes something that you don't even think about. When you leave work or when you leave school, you just turn right. That's the thing you do without even thinking about it. But today, you have a special task. You have to go to the grocery store, which requires you to inhibit that impulse, that automatic response of going home, turning right, and instead you have to go left. So presumably it would be the anterior cingulate, which helps you to inhibit the tendency to go home, to turn right, and to go to the grocery store instead. Let me see the time. Yeah, that is actually, let me see. Hold on. Yeah, we're making great time. So let's take a break now. And I'm going to stop this video and then keep the meeting going. But it's 7:53 here. I think let's just meet back up at 8 o'clock. So if you need to go to the bathroom or whatever, that's fine. Let's meet back here at 8 o'clock.